Hello everyone, hope you're doing well. I'm Prakash and I'm planning to start a series of data structure and algorithms for especially for folks or students who are coming from college and preparing for campus, or even if somebody wants to revise the concepts in case they want to you know make a career move and career growth, and targeting the companies where these topics are like most relevant. Of course, these topics can come in any interview for that matter, but some companies, especially that have business of you know uh, software development, basically that targets these questions more. Of course, and companies that may be focusing more on uh, solutions and services. I'm not saying that they won't be asking, but the degree of questions of this nature may be less. But irrespective of type of the companies, this question can come. So you should be prepared for it. And I hope that this series of videos on these topics are going to help you on building the foundations of these topics. Um, Frankly speaking, these topics are not complex. However, they require structured approach and logical approach to learn the concepts and also uh, do the experimentation. Uh, Learning the concept alone may not be enough. So basically, one also has to experiment them to understand that how these things are really working under the hood, and after that you can be sure that if you can implement that in any popular languages, whether it's like C sharp, Java, or C. So my focus is going to be more on logics and what it takes for algorithm to come in, and why this algorithm exists, and less on whether it's like less on the programming language. Of course, I'll be taking programming language, at least one to illustrate you how the logics work. However, the main focus is still going to be on underlying concepts, and so that if you understand it, you can implement in pretty much any language, right? Logics are more important. So with that mindset, let's begin. So this is the data structure definition as per Wikipedia. Uh, Wikipedia is known to be a most authentic, I would say, source available for developers and for other folks to refer. And this is what they defined what is data structure. So as the name suggests, right, data structure is what? Structure of data? Someone can argue. Yeah, it is true. However, it is not enough. So uh, basically what more to it is that of course there is a structure and there is a management on how this structure is going to be related. There are also things that you need to take care about storage part, that how data is going to be stored, what format it is going to be, and the most important thing is that how it will be accessed and modified. In some cases, maybe one maybe wants to care more on access part, that is a fetch operation, and in other cases, maybe somebody is bothered more on the insert and updates and maybe deletes. That comes in the category of modification. However, both are required at some point. So we will, so this data structure deals with both kind of approach rather. Other definition is, or you can see in other words, what they're saying is that data structure is a collection of data values. Of course, within a structure there would be some values and how they're related, relationships among them. And and also what are different operations can be done on them. So there are three things. One is structure, or you can say four things. One is structure, second is value underneath, third is how they're related, and four, what are different operations can be performed on them. As we few minutes back we were talking about, operations could be access operation, or you can say fetch operation, and modification operation, it could be insert, delete, and update. Moving on. So what are the types of data structure? So types, let's look at a high level. So there are at a high level there are two major types can be classified. Of course, you can find all kind of you can say division, but these are the commonly understood types. So one is primitive types that has typical traditional built-in data types also, you can say, whether it's like integer, float, string, character, date, bool, and there could be more. I have not added, however there could be more like currencies and decimals, and the types that generally comes in built in the system. Non-primitives are basically where somebody has to create them in most cases, like sometimes they also call it as a derived types. So again, these types can be of again two types further like broken down. One is called linear and another is called non-linear. When we say linear, basically what we are trying to say here is that the data is going to be stored in a sequential manner, as the name suggests, linear. In the non-linear, it's not the case, it's just opposite, where data would be stored in a either tree format or graph format or some kind of a hash. Of course, we'll be going through them in greater details later, but at a high level, these are categories that you have primitive, you have non-primitive, and under non-primitive you have data that can be stored sequentially and data that cannot be stored sequentially. Okay. Okay, so small quiz just to create an interest and kind of you can try yourself. So look at the first one, how it looks like, what kind of data type, or let's not say the data type, what kind of data structure it can be. Think about it. What about next one? It looks like something that we see very often when we go outside. I'm just giving some hints, right? Uh, if you go to somewhere and there is a lot of crowd, think about it, that becomes. Third one from left. Yeah, we spoke about it a short while. Again, there is something. Look at some kind of a pipe that is open from both end, right? And what is last? Again, there is a box. However, it is not closed from both ends. It just open. Sorry, it's not open at both ends, and it just open at one end. Okay. I hope you have the answers ready. Here you go. Okay, so the first one is array. Why array? Array is basically a sequential storage of the data. As you can see, the data is stored in a sequential manner. Sometimes you can also say index manner. Our sequential is more, I would say, a bit clearer to understand. Next is we call it list, or you can say in this case linked list, because they are also linked. So this is a linked list. Third one is, as it looks like, it's like you can imagine a tree where a lot of structure on it. So basically it's a tree, and then you have a data structure that has both ends open, so that is a queue. So as you can see, whichever data will come first, that will be going first. So there is also the concept called first in, first out. So FIFO, in short, FIFO people call it. So Q is a data structure that supports FIFO principle. Look at the last one, that is the stack. So what is happening here? Okay, so structure is stack is something that, as you can see, is only open at one end. So data will be inserting as well as deleting from the same end. So contrary to or opposite to queue, it is not FIFO, rather LIFO. What is LIFO? Last in, first out. So the data that went last will come out first because it is stacking up, right? So if it is stacking up, the data that you will insert last means earliest or soonest, whatever you call it, that is going to be out again because it is open at only at one end. Okay, hope this helps you to understand the basics of it. Moving on. Again, as we talked about categories, we have linear category, a linear data structure. So we're talking about linear, and we talked that data is arranged and stored in a sequential manner. So all these are like examples of that. Array, again example of linear, and it has the fixed size. So one has to define the size of it, like how many members are going to be there, or what's the length of data that has to be defined, uh, you know, basically before you start using it. So that is called array. Next is called linked list. There are other variations of it. Some people call it array list, some people call list. But we're talking about here linked list, that is more popular names to understand. So it has one additional flexibility on top of arrays, that its size is not fixed. So size is dynamic. So you can decide on the run that, or in the execution, or rather you can say before, you don't need to declare the size of the data beforehand. Of course, when you give this flexibility, there are some complexity also comes naturally, and we'll talk more on what are those complexity that come when we make a list as a variable size. Third one is stack. We just looked at a short while back that stack is something just, as we say, right? Please stack means what? We just keep one after the another, right? So adding and removing both happens from top, and that is called LIFO, LIFO, last in, first out. The last one is queue. It is like both ends, you can imagine as a box, or not box but circular kind of you know can say container, long one, and it has opened from both ends. So basically, we add from back and remove from front. So it's like data is keep coming. So that is a queue. Coming to non-linear data structure. So as the name suggests, data is not linear. So data is stored in a either hierarchical way or some kind of a graphics way. Not graphics, sorry, graph. We'll talk more when we look into details. So like you can imagine at different points and it is connected. And hash table. So hash table is used a lot, and there are some types which are like support hash. So there is always a function called hash function. So basically it defines that how the data from at one end to be connected to the other end, and it maintains the data and hash code separately. So we'll be talking more once we reach to that place. So these are the typical data structures of nonlinear. They are not only there are more, but we are talking about the most commonly used ones. Again, a category that basically you will understand more once you start using any of the OOPS languages, whether it's like you know C Sharp, Java, or maybe partly